السلام عليكم ورحمة الله وبركاته أبنائي وبناتي طلبة وطالبات الصف الثاني عشر متقدم. بنراجع مع بعض هيكل امتحان الفيزياء العام 2022-2023 وخاصة للي بيدرسوا باللغة الإنجليزية، فهتخليكم معايا step by step. The first question بيقول لك show that by definition that electric current it's I measured in ampere is related to net charge. Net charge is Q and measured in coulomb through the equation between current and the charge related to time. I think all of us know that I it's equal to Q over T. I current measured in amp, Q is a charge measured in coulomb, and the T is time measured in second. Define electric current and specify its unit as ampere, and ampere equal coulomb over second, as you see from this equation. 1 ampere equal 1 coulomb over 1 second. The first of all, electric current, the symbol for electric current is I. A unit of measurement is ampere. Electric current measured by a meter. A meter is connected to the circuit in series. The simple circuit consists of battery, resistance, and we can put a meter at anywhere in the same path. In this case, a meter connected in what? In series, as you see, battery, resistance, and a meter to measure current flow through this circuit. The definition for electric current is the total charge passing through a specific point in a specific time divided by that time. This is the definition for what? For current. And I is differentiation for what? For a charge during the time, so that I it's equal dq over dt, and dq is integration, I is differentiation, q is integration from time equal initial to time equal final for I dt. In the same page number 117, there is a law of conservation of a charge. Law of conservation of a charge said the same amount of a charge flow into one end of the conductor. If we have conductor like this, the charge enter this side, it must equal the charge leave this side at the same time. Charge in equal charge out at the same what? At the same time. It's a law of conservation of a charge. If at the same amount of a charge flow into one end of the conductor as emerge from the other end, and 1 ampere it's equal to what? 1 coulomb over 1 second. Let's start with solving a problem. First question is 5.2 times 10 to the power 20 electrons. It's a number of electrons, so that number of electrons it's n. Pass a specific point of a uniform conductor during 120 seconds. It's a time. What is the current? What is the current? He asked about I, unknown, and measured in ampere. To solve this problem, we need to use two equations. The first step or first equation, we use it. Q, it's equal N multiply E. N, number of electrons or number of protons. E is elementary charge. Elementary charge, it's equal 1.6 multiply 10 to negative 19. So that Q, it's equal to 5.2 times 10 to the power 20 multiply 1.6 times 10 to negative 19. It's elementary charge. The answer is, using your calculator to get the answer, 5.2 times 10 to the power 20 multiply 1.6 times 10 negative 19. The answer is 83.2 coulomb. 83.2 coulomb. The second step to solve this problem, he asked about current. I, it's equal Q over time. We have Q, 83.2, divide time 120 seconds. The answer is, divide 120 seconds, the answer 0.69 ampere. The second question, A current of 0.5 amp, it's I. Flow in a wire for 650 second time. How much charge? He asked about a charge. Unknown measured in Coulomb. I think it's direct. How much charge pass through any point in this wire during this time? From the same equation, I equal Q over T, so that Q equal I multiply T. I 0.5 times T 650. The answer is 325 Coulomb. Third question, determine the current flowing through conductor at T equal to second. He asked about current. Equal what at this time? If the charge flow is given by the equation, if we have equation for charge, we must derivative this respective to time. Differentiate this so that I equal dq over dt derivative. How can we derive this one? 2 multiply 8, it's equal 16 t plus 40. Derivative for 40 is 4, only 4. Derivative for negative 2, it's 0. Then I at time equal 2 seconds. We substitute t with 2. 16 multiply 2 plus 4 using your calculator. 16 times 2 plus 4. The answer is 36 ampere at time equal to. At a different time, the current will be changed also. Number 4. A current flows through a conductor given by equation for the current. We have equation for a charge, we make derivative. We have equation for current, we make integration for current. How much charge? Charge equal unknown Coulomb. Pass through a point of the conductor of this conductor during the time interval t equals 0, it's t initial, to t equal to second, t final. Q, it's equal integration from t initial to t final for what? For current, it respect to t. It's equal integration from 0 to 2. We just write the current equation, 2t squared plus 5 dt. Using your calculator, you press this button and write the equation 2 multiply alpha x square plus 5. Down we write 0, up we write 2. We write x instead of what? Instead of t. X is unknown as t is unknown. Then press equal, the answer is 15.3. 15.3 Coulomb. Number 5. Which of the following equivalent is the unit of the electric current? I think all of us know the equation for electric current. It's equal Q over T. Electric current is ampere. 1 amp is equal to 1 Coulomb over 1 second. 1 Coulomb over 1 second, it's equal Coulomb multiply second to the negative 1. They are the same. So that the answer is Coulomb times second to the power negative 1. Number 6. How many protons? Ask about n, number of protons without unit, are in the beam traveling with the speed of light. The speed of light, it's equal 3 multiply 10 to the power 8 meter per second. It's the speed of light. We can write it c or we can write it v. They are same. And carrying 11 milliamp. 11 milliamp, it's I. Milli multiply 10 to the negative 3. Of current around 6.3 kilometer. Kilo multiply 10 to power 3. It's a distance, we can write it d. Circumference of the ring. First of all, we need number of proton, so that I will use this equation. Number of proton, it's equal Q over E, because Q is equal N multiply E. We haven't Q. Q equal I multiply T. We have I, but we haven't T. Oh, I can use V. It's equal distance over time. We have velocity, we have speed, we have distance, we can calculate time. So that the first step, I will use this equation. T equal distance over speed. Distance is 6.3 multiplied 10 to power 3 to convert from kilometer to meter. Divide by 3 times 10 to power 8 speed of light. Using your calculator, 6.3 into 10 power 3 over 3 into 10 power 8. The answer is 21 times 10 to negative 6 seconds. It's the first step. Now I can calculate charge. Charge, it's equal I times T. We have I 11 milliampere 11 multiply 10 to negative 3 times time in calculator 21 multiply 10 to negative 6. The answer is this number times 11 into 10 negative 3. It's 2.31 times 10 to negative 7 coulomb. The third step, I write it in scientific notation. Okay, 2.31 times 10 to negative 7, it's the same to 131 times 10 to negative 9, the same number. Number 3, number of electron is equal Q over elementary charge. 2.31 into 10 negative 7 divide 1.6 times 10 to negative 19. The answer divide answer over 1.6 times 10 negative 19. The answer is 1.44 times 10 power 12. 44 times 10 power 12 protons. Where is the answer? First one. The second question, define the current density J as a current per unit area. Current is I per unit area A flowing through conductor, page number 119. Current density, the sign for current density is J and the unit is ampere per meter square. It's a vector quantity. Vector quantity, what it mean? It mean direction and magnitude. The direction of current density in the same direction of what? Conventional current, or in the same direction of positive charge. Where is the positive charge move? It's current density. In the direction of movement of positive charge or in the direction of conventional current. Definition for current density. Current flowing per unit area. J, it's equal I over A. I is current, A is area. So that J it measured by ampere over meter square. Ampere for current, meter square for area. And the current is integration for J dot dA. The conductor in which no current, if there is no current in conductor, it means conduction electron move randomly. The conductor, what the meaning by conductor? What is the difference between conductor and insulator? Conductor have or conductor obtain free electron. This free electron is called conduction electron. The conductor in which no current flow, if there is no current in the conductor, it means electron move randomly in the conductor. When the current flow, if there is current in the conductor, the electron continuous, it will continue to move randomly, but there is another motion in the same direction by slow speed, it named drift speed. When the current flows through the conductor, the electron continue to move randomly, but it also have drift speed, Vd. This is speed in the direction opposite to direction of the electric field. Which electric field? Electric field that causes the current. Drift speed is very slow. Look to this figure. As you see, we have I is what? I is current. In the same direction with J, what is J? Current density. And in same direction of E is what? Electric field. Electric field make positive charge move to the right. and electric field make negatively charged or electron move to the left. Electron move with a speed, very slow speed, it's called Vd or drift speed or drift velocity. Current, electric field, current density in the same direction, opposite to what? Drift speed. In this figure, the electron move from right to left, and conventional current move from left to right in the same direction of electric field and current density. Question number 1. A current of 2.3 amp, its I, is flowing through cylindrical conductor that has a diameter. We have a diameter divided by 2 to calculate radius. R equal 1.5 divide 2 centimeter multiply 10 to the negative 2 to convert it to meter. What is the current density? J equal what? Ampere per meter square. I think all of us know J equal I over A. It's equal I area equal by R square. It means 2.3 over by 1.5 divide 2, it's 0.75. Multiply 10 to negative 2 squared. Using a calculator, 2.3 over shift by times 0.75 into 10 negative 2 squared. The answer is 1.3 times 10 power 4. 1.3 into 10 power 4 ampere per meter square. Question number 2. A current flows through two conductors conducting in series. Conducting in series, it means I1 equal I2. I is constant. The current flow through this one, it's equal to the current flow in the other metal. If the radius of first conductor is equal to half of the second one, R for conductor number 1 is equal half of R to the conductor number 2. What is the ratio of their current densities? J1 over J2. J1 over J2, it's equal I1 divided by R1 square. This is for conductor number 1. Divide I2 over by R2 square. Just to write the equation two times. We can convert division to multiply and reverse this fraction. We write by R2 square over I2, and this I1 over by R1 square. J1 over J2. I1 and I2 is the same. We can cancel it. I1 cancel with I2. Equal each other. Connected in series. And by cancel with by. Now J1 over J2, it's equal R2 square over R1 square. It means R2 square over R1 is 0.5 R2. 0.5 square R2 square. I only substitute R1, I remove R1 and write 0.5 R2. So that 0.5 will be squared and R2 squared also. Now we can cancel what? We can cancel R2 square with R2 square. There is 1 here. And the answer is 1 over 0.5 square using your calculator. 1 over 0.5 square. The answer is 4. The ratio equal to 4. Question number 3. A current with density it's J, is flowing through a wire with 1.5 into 10 negative 6 meter square, its area, cross-sectional area. What is the amount of a charge? A charge is Q, it measured by Coulomb, passed through the specific point of this wire during 20 seconds, it's time. All of us know Q, it's equal I multiply T, but we haven't I. And J, it's equal I over A. so that we can write I equal J multiply area. First step, I equal J multiply area, density multiply area. We have density 250, area 1.5, multiply 10 negative 6. Using your calculator, 250 times 1.5 into 10 negative 6. It's 375. We can write it 3.75 times 10 negative 4 ampere. The second step, Q, it's equal I times T. Answer multiply time, it's 20. Answer times 20 equal 7.5 times 10 negative 3. 7.5 times 10 negative 3 coulomb. Our answer, this one, we can write it 7.5 millicoulomb or keep it like that. Number 3, recall and apply Ohm's law. Ohm's law, I equal delta V over R. I is current, delta V potential difference, R is resistance, or R equal delta V over I, resistance, potential difference, current, or delta V equal I multiply R. The first question, which of the following equivalent to unit of electric resistance? We can use this one. R equal delta V over I, so that Ohm equal voltage over ampere. It means voltage multiply ampere to power negative 1. The second question, a potential difference is delta V, 12 volt, is applied across a wire of a cross-sectional area millimeter square multiply 10 to negative 3 squared. Why multiply 10 to the negative 3 squared? Because it's a millimeter square. It means 10 to the negative 6. And the length is L, kilo times 10 power 3 or times 1000. The current passing through the wire is this number. What is the resistance? Resistance measured in ohm. We don't need all of these numbers. Just R equal delta V over I. It's equal delta V12, and I is what? 3.2 into 10 negative 3. Using a calculator, 12 over 3.2 times 10 to negative 3. The answer is 3750 ohm. Question number 3. A light bulb connected to a source of EMF. There is 6.2 volt delta V drop across a light bulb, and a current is I, 4.1 ampere, flowing through the light bulb. What is the resistance? R equal what? Ohm's law. R equal delta V over I. 6.2 over 4.1. 6.2 divide 4.1. The answer is 1.51 ohms.